So today you're presented with a problem that asks you to do a few things. Number one, it said rectangle MNPQ has these vertices. Draw the rectangle, rotate it 180 degrees about 4,7, reflect the rotated image through 7, 0, and then find the coordinates of the final image. We need a volunteer to show us how you did what you did.
So the first thing we did is that we drew out the rectangle with the coordinates given to us. So this is the shape. And then it said to rotate it 180 degrees about 0.47. So we made 0.47 and we rotated it counterclockwise and we got there. And it said to draw like a vertical line, so we set from 0.70. So we went from 0.70 all the way up, and we just reflected it from what we have.
You said you rotated it counterclockwise. Does it matter if you rotate it counterclockwise or clockwise?
It doesn't matter because it's 180 is the same a half, so it will always end up in the same place if you do 180.
So if it asks you for 90 degrees, does direction matter?
Then it does.
Right, perfect. Okay. So how were you able to confirm that this first image ends up here? Because a turn, especially outside of the object, because in this case, the turning point's 4,7. It falls outside of the object. How was your group able to confirm that the image ends up over here?
Because then after we used a cutout
Okay.
to help.
Does anybody want to model with a cutout? Let's just confirm their answer, even though it looks right.
So this is what I did. So this is a point N right here. So it kind of lines up. Here's point N, here's point P, here's point Q, here's point M. So first, so like, you can just basically do it like this, but like just make sure it's on the point N, and just move it 1 meter square away. So like, kind of like that.
Okay.
Like that. So then I like basically rotated it until like it came like until here. So basically just I rotated it from 0.47 and then I moved it 1 block ahead because it's 1 block away.
So let's break this down for you. You can go have a seat. Thank you. So first of all, I like how this, by making a cutout, I like the original idea of labeling the points on the cutout. So this group labeled their points on the cutout. So now, if the turn center was N, this becomes a little bit easier because it doesn't move from here. So a 90-degree turn would stop at about here. A 180 stops at about, say, here. But the turn center is away. So since the turn center is right here, it's very difficult to see where it's going to end up. So even if you turned it from point N and you made your proper turn, 180, the turn center is 1 square away from point N. If it's 1 square away, you would bring it up 2 spots. It's almost like a reflection. You know when you have a reflection, it's 1 away on one side, it has to also be 1 away on the other side. Now, imagine this, and I'm going to put like a little dotted line here, that it's like a reflection. Because it's so hard to visualize turning outside the turn center. So, this group, what they were doing is they were moving it away from the turn center after. So since you moved it one direction, one section, you move it 2. Okay. And then I see that the reflected line, the points all match up. The last question was to give the last part was asking the coordinates for the final image. This group recorded the coordinates down here. 7:11 is correct. 10:8 is correct. 12:10 is correct. 9:13 is correct.